We are going to simplify exponents. We're going to do negative exponents. Okay, I'm going to show you a process. You can do your own thing, but I'm going to show you a process I think will work. Now you have to go to the second sheet. This is just the cover sheet, but then I fixed it up this morning, so it's not all together. You want to go to this one, single-sided. Okay, and iPad should be down. And you need to check your answers. The answers to the worksheet for today are online. Okay, everybody got to the right place? Okay, close your iPad, please. Okay, we're going to expand this. We're going to do this problem two ways. This is x times x. And this is the part, if you don't pay attention to this part, you're probably not going to understand what's going to happen. Well, I need 5 of these x's. And we can reduce that, can't we? X goes into x once. X goes into that x once. We do the same thing over here. Now, what's in the numerator? No, what's in the numerator, not 0? 1. And in the denominator, there's x what? 1, 2, 3, cubed. Now, yesterday, we did division. And remember what we do with exponents? Do you remember what we do with exponents? Not for division. We subtract. Jens, put your iPad away, please. No, not right now. Okay, China. So this is 2 minus 5, or subtract 5. So this is x to the negative 3. Now, I did the problem two ways. Okay, China, I got one answer this way. Girls, later. Joey. And I do it this way. Now, it's the same problem. What's got to be true about these two things? Powers, what has to be true about these two things? They have to be equal. So x to the negative 3 equals 1 over x cubed. So a negative exponent, and put your iPad away, please. A negative exponent does not make a negative number. It flips the number. You do a reciprocal. So when you see a negative exponent, I don't want it, it's the reciprocal of this. You can see I could do it this way, or I could do it that way, which means these two things are the same. What's x to the negative 1? You take x over 1 and flip it and make this a positive exponent. So it's 1 over x. And that's really all that's new. Now, I like to get rid of my negative exponents first thing when I do problems. And I'll show you my little technique here. Why do we have these negative exponents? Because you guys have seen this in science class. What's 10 to the negative 3? It's 1 over 10 cubed, that's right. Which, it's 1 over 1,000. What is that as a decimal? Jake? Joey? What is this as a decimal? 0.001. So we use negative exponents all the time. It's just a notation for a fraction that's upside down. You got to reciprocate it. So what about this one? What's this going to be? China, how do I do this one? I want a positive exponent. So what am I going to do? I'm going to put x cubed, x in the bottom, 1, and we're going to flip it, and this is going to become a positive number. That's all there is to it. Sometimes I get the negatives in the denominator. I don't like that. I don't like negative exponents because I don't know what they mean. So I change them to positive. So what's this one equal to? X squared over 1. So there's two changes. You reciprocal it, you flip it if you want to think of it that way, and you make that a positive exponent. Okay, China, question? So it's not easy. It wasn't easy to type either. So what is x to the negative n? Jake, what's x to the negative n? You guys, put your iPads down, please. Now close them. Joey, you can do that later. China. Shh. But you need to be quiet. What's this one, China? One over x to the n. Jake, what's the other one? X to the n over 1, which I don't need the 1, but I do need the 1 here, though. Okay, So let's try some problems. Now, I don't like to work with negative exponents. If they're negative, I get rid of them. So all I do is I look at this and I say, I have one x in the numerator and 2 in the denominator. Where do I have more x's, Powers? Where do I have more x's? So that's x here, and what goes up here? 1. Whoever's playing the music, don't. Okay, what about this one? How many? I have 9. There's 7 here. Still subtract. 2. Okay? So we're going to write these with positive exponents. So now I break them up. Now we're getting harder. I have y to the 10th. There aren't any other y's. So it's y to the 10th. And I always put my letters, my variables, where there's more. So I'm going to put my fraction bar here. I'm assuming I have a denominator. The t's. I've got 6 t's here and 2 here. Where are they going to end up? On the top. So it's t to the what? 4th. How about the s's? S to the 3rd. I'd like to keep them positive. When I get, and you will see negative ones. What is it? Okay, let's do this. Okay. Now, do you remember what to do with this? Do you remember what to do with the 3 here? Lexi, do you remember what to do with the 3? You have to distribute. Oh, this was a while ago. Powers, what do you get? What do you get? Because what does this mean? What's c to the 0, by the way? 1. So you have ab that's cubed. What does it mean? Hey, guys, I want to get to this lesson. It's ab times ab times ab. How many a's are there? 3. How many b's are there? 1, 2. That's 3. Well, I'm not going to skip steps because I want to make sure you understand it. And then I've got b cubed over c at times c to the 6th. Now I can get rid of them, okay? And I'm left with a cubed over c to the 6th. Okay? I know I've looked at some of the papers and you guys are not all correct, so you need to check. Got to check. Okay, what about this? X squared over x to the 7th. Where are there more? Matt? Where do I have more? X's. How many more? Okay, what's in the numerator? Oh, you can't just doesn't go away. There's a number there. 1. Okay, China, could you please sit down? No, I didn't. No. Wait till I'm done. Try this one. What do you have to do with that 5? We have to distribute it. Okay, Lexi, we're going to distribute this. So it's a to the what? Negative 15. B to the 10th. Now is where it gets a little trickier. Okay. I could subtract exponents. It just gets hard. Okay, Powers, what I do, and I think the easiest way to do this, is to still eliminate all those negative exponents. So I'm just going to leave the b's alone because they're positive. The a to the 8th is positive, but I don't like this a to the negative 15th. So where am I going to put that? On the bottom, and it'll be 15. Guys, then this is, well, what happens here? What's that going to give me? B to the 9th. Where is it going to be, top or bottom? Yep. And it's a to the what? 23rd. Very good, Joey. Now, I would probably here, guys, I would probably simplify this first. Let's just do this one. Where are the D's going to be? Brisbane. I have 4 here, 11 there. Where are they going to be? Numerator or denominator? That's right. And then you subtract. 11 minus 4 is 11 minus 4 is? That would be 12. Now what about this e to the negative 9? Where should that go? I don't like negatives. So if I don't want to have it, if I don't want that negative, it has to change positions. So it's e to the 9. And what's still in the numerator? Joey? What's going to be in the numerator? Yeah, I know. What's that going to be? Now, what do? You remember what you do with exponents? When you're multiplying, what do you do with the exponents? No, you add them. So that's what? Negative 12. You're close. Okay, I don't like those negatives. So I have 1 over d to the 7th, e to the 9th, and I'm going to fix that one. That's in the numerator right now. So I'm going to put it here, and that will become positive 12. So this is 1 over what? How many d's do I have altogether? I have 7 here, 12 here. How many is that altogether? 19. And e to the 9th. Okay? My recommendation is to get rid of those negatives, because otherwise, you know, you could do 4 minus 11. I don't know. I just think it's harder. So when you get to a problem, just rewrite everything with positive exponents, and I think everything's going to be a lot easier. I'm going to do it the other way. Okay, so I have I have 2 worksheets for you. And the worksheets, oh, there it is.